Listen up, folks. We all know that money is the king of the castle in today's world, and there is a gazillion ways to stack those coins and become a riches for life kind of person. But hold the phone. Did someone just say you can make a cool $1,000,000 with just math? Yep, you heard that right, my friend. The Riemann Hypothesis, one of the most notorious conundrums in mathematics, is offering $1,000,000 to anyone who can solve it. So brush up on those formulas, grab your calculator and get ready to hit the jackpot. Yes man, math never looked so good. Hello and welcome to this video on the Riemann Hypothesis. Today we are going to delve into the world of number theory and explore one of the most famous unsolved problems in mathematics. So buckle up and get ready to learn something new. But first thing comes first. Who is Bernhard Riemann? Well, Bernhard Riemann was a German mathematician who is best known for his contributions to the field of mathematics. He made several important contributions to mathematics during his short but impactful career. One of his most notable contributions was the introduction of Riemann surfaces, which are now widely used in the study of multi-valued functions and complex analysis. Another significant contribution was his work on the Riemann zeta function, which he used to study the distribution of prime numbers. Now, let's talk about what the Riemann hypothesis is. Simply put, the Riemann hypothesis is a conjecture in number theory that states that all non-trivial zeros of the Riemann zeta function lie on the critical line of 1 divided by 2. But what is the Riemann zeta function? Well, the Riemann zeta function encodes the distribution of prime numbers, and it is defined as the sum of an infinite series for any complex number. The Riemann hypothesis, a conjecture that has captivated mathematicians for over a century and a half, is a statement about the mysterious and elusive Riemann zeta function. At the heart of this conjecture lies a tantalizing idea that all the non-trivial zeros of this mysterious function line up perfectly on a critical line, with the real part of each zero equaling a single fixed value of 1 divided by 2. Think of it this way: the Riemann zeta function is like a grand symphony, with each non-trivial zero representing a unique note. The Riemann hypothesis suggests that these notes all align perfectly on a single critical line with a real part of 1 divided by 2 serving as the conductor and leading the entire group in harmony. Alrighty folks, buckle up for a wild ride because understanding the Riemann hypothesis is a piece of cake, as easy as pie if you will. But hold your horses, my friend, because actually resolving it, well, that's a whole different story. It's like trying to climb Mount Everest with one hand tied behind your back, not exactly a walk in the park. But first, why is this conjecture so important? Well, the Riemann hypothesis has important implications for the distribution of prime numbers and has far-reaching consequences in areas such as cryptography and quantum physics. For instance, in cryptography, prime numbers are used as the basis for many encryption algorithms, so a better understanding of their distribution would lead to stronger encryption systems. Also, in quantum physics, the Riemann hypothesis is connected to the distribution of energy levels in certain physical systems, and a proof could lead to new insights in this field as well. And now comes the hard part. Despite being first stated over 150 years ago, this conjecture remains one of the most famous unsolved problems in mathematics. Despite much effort and the contribution of many mathematicians, a proof or even a counterexample has not been found. This conjecture has challenged mathematicians for generations and continues to be a source of fascination and interest. Many mathematicians and researchers have attempted to prove or disprove the Riemann hypothesis using a variety of techniques and methods, including analytical and computational approaches. Despite these efforts, the conjecture remains unproven. The difficulty in finding a proof or counterexample is due to the complex nature of the Riemann zeta function and the distribution of prime numbers, which are still not fully understood. Discovery of a proof or counterexample would have significant implications in the field of mathematics and beyond. A proof of the Riemann hypothesis would bring us one step closer to understanding the distribution of prime numbers and the patterns they form, which has far-reaching consequences in areas such as cryptography and quantum physics, as I said. On the other hand, a counterexample will demonstrate that the Riemann hypothesis is false and open up new avenues for research and exploration. Alrighty folks, are you feeling lucky? Ready to put your math skills on the ultimate test and attempt to crack the legendary Riemann hypothesis? The jackpot is waiting for you. Just imagine all those bragging rights. So let's hear it in the comments. Who is ready to take on this mathematical masterpiece? And that's it for this video. I hope you enjoyed learning about this fascinating topic and that you now have a better understanding of what the Riemann hypothesis is and why it is important. If you want to learn more, be sure to check out some of the resources in the description below. Thanks for watching.